Okay, this lesson is on sets and subsets. This was taught in 6th and 7th grade. So in 8th grade, it just builds on what was already taught. So it's talking about categories in numbers. So we have different groups of numbers. If you could draw a number line in your notes, in the middle put 0. So in a different color, I'm going to write 1, 2, 3, 4, 5. So everything that you see in red right here, these are the numbers that we count by. If I was to say the number of students I have, I wouldn't start with 0. I would say I have 1 student, 2 students, 3 students, 4 students, 5 students. So everything that you see here in red are the numbers that we naturally count by. So these are called natural, or sometimes they'll call them counting numbers, because that's how you use these numbers to count. So if you take all of your natural counting numbers and you include 0, that would be your category of whole numbers. So whole numbers are everything that you see in red, the natural counting numbers, and 0. So I'm going to start a graphic organizer down here in the middle. So your smallest set or category of numbers is natural numbers, because it's only what you see in red and beyond. It goes to infinity. Natural numbers. So the next size group, category, subset of numbers would be your whole numbers, because whole numbers is all of your natural numbers, but it also includes 0. Alright, so then behind the 0, so everything this way is positive, because we only count by positives when we're counting. So this way is where we have our negatives, behind the 0. So this is the next size up in groups of numbers. So we started with natural, which is the smallest group. Then we expanded by 1 number, 0, which gave me whole numbers. So if I took everything that you see here and then I included all of what you see, the negative coming behind the 0, that's what we call the category of numbers of integers. So integers is 0 and all of these whole positive numbers, and it includes all of these negative numbers behind 0. Notice none of them are decimals or fractions. So my next size up is going to be integers. Okay. So in between these whole numbers, whether it be positive or negative, is where we find decimals like 2.5 and fractions like -3 and 1/2, or we have 4.25. All of these can be written as a fraction. This is a fraction, but decimals are also fractions. Decimals and fractions are not natural, they are not whole, they are not integers, but they are rational numbers. So rational numbers, let's write this here, are any number that can be written as a fraction. So these already are fractions. A decimal can be converted into a fraction, but also everything that you see here on the number line below, the -5 all the way to the +5, can also be written as a fraction, because any of these numbers, if you put it over 1 as your denominator, there's your fraction. +3 over 1 still has the same value of 3. And it's a fraction. So any of these numbers can be placed over the denominator of 1. So everything that you see here is a rational number, which makes that group or category of numbers the largest. So then we have a different category of numbers, and that would include numbers like pi. Now pi is one of those decimals that goes forever and ever and ever with no rhyme or reason. It's 3.1498621. There's no way I could write a fraction from pi. Another one is the square root of 2. If I was to plug that into the calculator, I would get a very long scrambled decimal behind it. And it would look something like this. So if I had 8.8630136, there's no way I can write that into a fraction. So this is in a different group. It's completely separate from the rational group, because since these can't be turned into fractions, these are called my irrationals. My irrational numbers. And if you know about prefixes in English, ir means not. So these are not rational, meaning I cannot write it as a fraction. So you might be thinking, well, what about repeating decimals? Those go on and on and on forever and ever. Well, they're a little different. If I have a repeater, like 0.33, that's a repeater, you know that you can turn that into 1/3. So that's rational. Just because that would say 0.333333 and forever and ever and ever, it still can be written as a fraction. Another one would be like this, 0.777 repeater, and it goes forever and ever. That also can be written as 7/9. So just because it's a repeating decimal and it goes forever and ever, these repeaters, since it's the same pattern, can be written as a fraction. A decimal like this is not a repeater. It has no rhyme or reason, no pattern. I can't write that into a fraction, and that's why these are irrational. But these are rational. So let's plug some numbers into our graphic organizer. So we said rational numbers are like 1/3 and 0.77 repeater and 2/7 and 0.23, which is 23/100. And then we have integers that are the negatives, -8, -6, -4. And whole numbers are they're the positives, 2 and also 0, don't forget 0, and 6 and 1. And then our natural numbers are the ones that we count by, so 8 and 10 and 56. And there you go. So today's assignment is to do pages for what you're going to turn in. Your independent practice is going to be pages 16, 17, and 18. And that is numbers 1 through 8. They're all spread out because the graphic organizers are kind of large, so they take up a lot of space. So let me know if you need any help.